Everyone, and welcome to our co-hosted webinar by Webhose and DataRobot. Thank you so much for attending. So let me introduce myself. I am Shah Schwartz, and I'm the VP of Customer Success here in Webhose.io. It means that I manage the technical support team, data operations, and that also means that I'm responsible for our team's commitment to help our users in getting great business results by ingesting quality web data feeds. Today, I'm co-hosting this webinar with Colin Priest of DataRobot. Colin, super excited to have you with us today. Do you want to tell us a few words about yourself?
Sure. I'm a data scientist, originally an actuary from the insurance industry. I now do a bit more in the space of thought leadership and helping executives choose the right use cases and run projects. I'm based in Singapore, and as I said, I work for DataRobot.
Right. Thank you so much, Colin. Now, everyone that you know a little bit about us, let's get this show on the road. Colin, the floor is yours.
Okay, so I'm going to give you a bit of an intro first, then talk about searching for news stories, and then about predicting which news stories will go viral. And after I've done a live demo, I'm also going to show you a couple of other things you can do with the same data, such as discovering which news stories are trending. So you've probably heard a lot of hype about artificial intelligence, but there's real things happening here. Now, Forrester says that AI-driven companies are going to take more than $1 trillion from their competitors by next year. But the problem with this is that it's been built only by data scientists in the past, and there's only a limited number of them. They're very valuable. It takes a long time to train them up, and it can take a really long time to get things done. And as the demand for AI increases, the supply of data scientists it just can't keep up with that. So I'd like to introduce DataRobot. We are an American-based company, but multinational. Founded in 2012, $250 million worth of funding, and we've built more than 1 billion models, machine learning models on the DataRobot cloud, plus more enterprise customers build them on their own clusters. We've got hundreds of staff, of which roughly half are data scientists and engineers, including some of the top-ranked data scientists in the world.
Thank you, Colin, and also thank you the last attendees that have just joined us. Here's Webhose in a nutshell. We are a web data provisioning company, or a DaaS, data as a service. We crawl the surface web, the darknet, and deeper dark web realms, and we make the data available to retrieve in machine-readable formats. We continuously scan, structure, clean, index, and store the data, and we make it available to consume on demand. Now, you can get the data either filtered by tapping into our different APIs, or everything per vertical through a Firehose connection. That would be all languages, all territories out there. So whether you're running your startup from your parents' garage, or in the need for web data to feed your app or dashboard or monitoring system, or you're a Fortune 500 company looking to stream surface web or darknet content into your data lakes, Webhose.io is the data for you. Take it away, Colin.
All right, so today I want to talk particularly about news stories. And about a year ago, I had a need to show how DataRobot could deal with text-heavy data. And I was looking around for news stories and how I could source them, and I came across Webhose, and it really was the right solution for me. And I was presenting to some journalists, and the world has changed in journalism. We're now in what is really a golden era of journalism. There's so much access to breadth and quality that the consumers have. But publishers are increasingly using economics to drive what's going on, because a lot of it's now become online. Basically, the more clicks you get, the more people visiting your site, the more you can charge for advertising. So it's quite vital to the the editors, that they find stories to publish and give higher prominence to that people are likely to click on and share with their friends and family. So searching for news stories on Webhose is pretty easy. They have an API, but I always start just with a simple query, and I play around with it to see what I can get out of it, and then I'll turn it into a production run that I call from my API. So here, for instance, I'm looking for stories that were published in US or Canada or Mexico, and the title of the story included something about soccer, and the story was shared at least once by the person who read it. And so Webhose generates all that data for me. And here's an example of one of the stories that came up matching. Here's a story saying that apparently watching soccer could be good for your health. So being a sports fan is good for your health, apparently. And it'll give me many for that. So that particular search was very restrictive. And at the time I ran this, I found 8 posts matching that. What I'm going to do today, though, is a broader set of news queries and an analyzing on that. I'm going to read in tens of thousands of stories that were collected over a period of about a month. And that includes things like the title, the text, who published it, when. Webhose adds a lot of useful flags onto the data that enhancing the data to make it more useful for me. Things like sentiment scores on the people and the organizations that are mentioned in the story, separating out the external links. They also give me this amazing thing, which is the viral score for the story. How it's a score from 0 to 10 of how much the story was shared by others. What I'm going to do with DataRobot is find the patterns, how these predict this. And I want to be able to predict the viral score for new stories that come along. So basically, I had 4 weeks worth of history. Each row here is a story. What I've got is a ID for each story. I've got the title, I've got the text. I had to scrunch it all up here, but that can be quite long. And a number of stats here, including many that Webhose has added to the story to make it more useful for me. Then after I've built a model, what I want to do is I've got a bunch of news stories, and maybe I'm thinking that, I'm the editor. Which ones are worthwhile me putting attention into? Which one should I put on the front page, for example? So I picked half a dozen here, and the data looks basically the same, except obviously I don't know the viral score yet. So I'm going to give you a live demo. The things to look for, there's best practices built in, there's guardrails to stop me doing silly things. I'm going to let it build everything for me automatically, but I could dive down and override things. And the thing that matters here for this type of use case is I've got to be able to understand the model and what it's doing and why. It's no good just knowing which stories are likely to be viral. I want to know why so I can make better decisions. There's other features here as well. So let me jump over to DataRobot. So I'm using DataRobot Cloud here. This particular one's hosted in the US, or there are other ones hosted around the world, including many of our customers that host it internally on their clusters. To create a project, I have to read in some data. So I'm going to do that now. There we go. I'm loading up that 4 weeks of data that I managed to extract out of Webhose using their API. And DataRobot's read that in, and DataRobot's an expert system. It's really, really clever. This was a comma delimited file. It's looking at the columns, and it's figuring out what's going on in each of them. And it's already started to flag which ones make no sense to me. For instance, don't use the ID. What I'm going to do now is I'm going to start building a model that predicts the viral scores. So the viral score here, as I was saying, goes from 0 to 10. I dropped out the ones that had 0. So I've only really got the one that goes from 1 to 10. Here are the most viral. Here are the ones that people just go, oh, yeah, I'm not going to share that. Here's the ones that get them excited and make them want to share. So I need to tell DataRobot, this is the outcome I want to predict. And then after that, basically, I just have to click the huge start button, and I'm going to let it make all the decisions for me. It's doing best practices. It's going to split out the rows and learn off some of them, and then test whether it's any good on the others. When it's finished doing that, it's going to look through all of these features we've got here, and it's going to tell me which ones look the most promising. And then out of a library of hundreds of algorithms, it's going to pick about 30 to 40 that make sense for this specific data. So we can see some of the data that exists in here. We've got who published it, when it was published, we've got the titles. There's obviously lots of different news story titles in here. We've got the text, and then we've got some of these features that Webhose has been adding. So for instance, they find all the people mentioned in the story, and they list which ones had negative sentiment, neutral sentiment, no sentiment, or positive sentiment. Similar with organizations and locations. They also find all the images that are in there, what labels go with those images, and what text was sitting underlying those images. This is pretty useful stuff. So if we look at, for instance, negative sentiment, there's anywhere from 0 up to about 8 or 9 different people that could have been mentioned negatively in a story. This data is pretty big. Rather than make you wait for me to process it, what I'm going to do is, just like in a cooking show, I'm going to jump to one I've already prepared. So here I am. Looking at the same sort of page here, you can see it's now ranked those data fields in terms of their likely usefulness. And we can already see that the text, it's been doing text processing, seems to be pretty promising. It's built for me 80 different algorithms that make sense on this data and rank them quite objectively from the least accurate up to the most accurate. Each one of these has some quite detailed processing in it, depending on what's going on, including the text that we've got here. Now, I don't want to take the software's word for it. I want to see if it's any good at predicting which stories go viral. So what we've got here, we've ranked all the news stories. This is the blue line here, from the predicted viral score. So we've got ones going from 1 all the way up to about 9 in terms of predictions. And we got the orange, which is for each group in here, what was the actual viral score. We can see we've got a pretty good job of ranking the stories by which ones are going to be most viral. In fact, in the top 3 or 4% here, what we've got is a predicted viral score of about 8.5 on average, 4 out of 10. And in fact, the actual was 8.8, even higher. So we're basically getting the ones that are most viral, but that's 3% of stories that are really going to get people excited. I want to understand why certain stories are going viral. So the next thing I look at is which of these inputs are the most valuable. And I can see here that the size of the publisher, the domain rank, so number 1 is the biggest, and we get into the thousands for the small publishers. That seems to matter, which makes sense. People are more likely to read from a big source and share from a big source. And then interestingly enough, it's the text of the story turns out to be slightly more important than the title. There goes my theory that people only read the title and got excited about that and shared it without reading the story. Now we get to see a number of other things, and we already see just here, about half a dozen down, one of the many added features that Webhose adds to the news stories, and more down here. So these fields that they're creating, while they're not sitting at the absolute top, they are still really important for me to figure out what is going to go viral. So I look here and I say, okay, I want to understand the most important ones. So I could look and say, I want to understand the text. What's going on? What is it in the text of the story that gets people to share the story? So here, red means it's most likely to be shared, blue means least likely, and then the size of the font is how often does that word or phrase appear in the data. It's really no surprise here that Trump appears in news stories quite a bit and that he's at the red end of the scale. People will, whether you love him or hate him, you want to talk about him and share the stories with everybody else. On the other hand, if we pick something that people are less excited about, London. Now, Americans really don't care much about that. These are the stories I've sourced here are primarily American. They don't really care about newsletters. So we're starting to see what sort of words and phrases are driving general stories over the past 4 weeks. And that's pretty good. I could do the same for the title of the story. So I flick over to that, it'll pop up as well. What we can see is that Trump appears the most common in the titles, but we can see slightly different things driving in the titles what gets people excited and wanting to share. Some of that is about who wrote it, but we can also see, for instance, Baltimore got some bit of interest here. We could see that, on the other hand, in terms of locations, Turkey and Nigeria, people didn't really want to share those. Amazon Prime and football, which I don't know if that means soccer or American football. I'd have to look at the title. They're the things people share less. So that all makes sense to me. The next thing I want to look at is some of the numerics and the categoricals. Which things are driving that in there? Now, we saw that the domain rank was important. What we can see here is that the less important the publisher, the less a news story is going to go viral. And there's a big difference once you get up into the top 10 or so. There's a big jump up here. Similarly, we could say, well, what time of the day does that matter to the viral score? And what we can see here is that stuff published just after midnight, in the late hours of the night, including just before midnight, that time period there seems to drive, when it's published, news stories that get people excited and make them want to share on social media. We could also look at day of the week, and it appears here that Saturday is the day of the week where you get the exciting stories. So they're the big picture patterns. So we've seen what's important, which data fields, and we've seen within each data field what's important with that, which is pretty damn amazing. The next thing I want to do is I want to look at individual stories and see what their predicted viral score is and why. So that's what I've got here. We can see this one, it's predicting basically this is going to go really viral. Why? And if I look at the title is the second most important reason why. Oh, Trump claimed that Baltimore is worse than Honduras. I can get why people want to share that story. And we can see it's actually the text was slightly more important than the title on this. So there are a number of words in the text of the story that are driving this going viral. We could pick another one beyond here. So let's pick the third one along. This is another one that's predicted to go viral. If we look at the text here, let's just go over. What we can see is that company Beyond Meat, that seems to be the hot thing in food at the moment. A vegetable based pseudo meat. So apparently it tastes like meat. I've really got to try this one day. I'm a bit suspicious. I'm a big meat eater, but I've been told that it really tastes and looks like meat, and that should be healthier for you. So that their shares dropped in trading. I can imagine people also sharing that, because the whole idea of vegetables that taste like meat is a pretty hot topic at the moment. People get very excited about that. What got less shares? Let's pick this one here. So basically it's saying this is towards the bottom. And if we look at the title, it's how to prepare your pets for an earthquake, or what you could be prepared for if an earthquake happens. Not the most debated of topics, even though it would be very important to the actual pet owners. So we can look at individual stories and we can see which ones are likely to go viral. This is on my training data, and why. Now, the next thing I want to do is I want to be able to put it into production. I want to get the examples that I had. And here we remember these examples here. Here's my new half a dozen stories, and I want to see which ones are most likely to go viral. So all I have to do is bring in that data. There we go. I'm loading that data up. Obviously, that doesn't take long to load up. It's only 6 rows. And once that's popped up, I'm going to, there we go, compute the predicted viral scores on that. And that won't take too long either. Once again, it's only 6 rows. And we don't have a huge number of inputs. We've got about 30 or 40 inputs, not really hundreds or thousands. While I've got that happening, I'm just going to set up here to grab a couple of extra fields. So I'm going to get the title when I download this, and I'm going to get the text. There we go. Right, so the predictions are done. I'm now going to download. Just putting those into a comma delimited file for me. And in the next 15 seconds or so, it's going to download that for me. There we go. Down it comes. And if I open that, I'm going to get a score for each one of them. Here we go. So this is the news story that it thinks is most likely to go closest to being viral. If I look at the title, it's about a $15 minimum wage. You know, basically would get to there via 2025. I can imagine that this really would be something that people would get quite excited about one way or the other, depending on what your politics and your beliefs are, and you'd be wanting to share that with your friends. So that makes sense. Here's the one that it thinks is going to be least viral. And this is it's a comic con about the Black Widow movie. Now, you might be really into the Black Widow movie, but it's not the sort of thing people are going to share as much. But we've known this for a long time, that this was going to come along. There's a lot more things in DataRobot I could show you, but rather than take your time for this, what I'm going to do is flick back to the slide deck and just run through some summaries here. So remember, we saw that it was pretty good at finding which stories go viral. It found which inputs matter for predicting virality. We were able to see what text drives viral stories. And in fact, one of the things I can do is within the text, I could highlight which words and phrases are making a story viral or not viral. So for instance, you know, we could see that, whoops, there we go. We could see that, you know, beginning with the word president, we're talking about senators, we've got Russia involved, we've got Donald Trump involved, the American people, those sorts of phrases are what's grabbing people's attention. What grabs their attention less? The Senate, they don't get excited about that, or Germany, and anything mentioning economics. Those parts of the story are things that people get less excited about. We saw that the domain drives it. We could have also seen that the number of hyperlinks in the story do drive how viral it is, although pretty much once you get to about 5, it's not making as much of a difference anymore. We could see what individual stories were ranked high or low. And before I finish, I just want to show you a couple of other cool things you could do with this data. I could figure out, instead of which ones are going to go viral, what stories are trending. So basically, I put in here the same data, but this time, instead of predicting the viral score, I go, is it from the latest 24 hours or is it from the previous 4 weeks? And if I build this now, red means it's from the latest 24 hours. Now, when I did this extract and built this model, the top story was that Liam Hemsworth and Miley Cyrus were getting divorced. And so we saw that in here. We saw that there were some stories about Israel, about children, but what we were seeing much less of were stories about Muller. That was just old news by now. And China, that had dropped out of the news. So there's Miley Cyrus and Liam Hemsworth. Again, they appear in lots of different ways here. So now I know that that's the hot story. I really don't follow that sort of story, but if I'm a publisher, I'm going, yeah, that's where I want to put my money for advertising. I can see why. We can see those stories up here. And here's what I was talking about. Miley Cyrus and Liam Hemsworth split 9 months after getting married. So I'm now going to open it up for questions and answers.
Yeah, Colin, first of all, thank you so much for this fascinating work. This is really, really interesting. And the reason why I'm so excited is also because this is exactly what Webhose is all about. We scan, structure, and clean and index the data and make it available for companies like DataRobot to be able to do magic over that data. So this is really, really interesting. A couple of questions for you. The first one is, what's the total runtime of the automated process? It seems like people just wanna go ahead and give it a try. So what's the total runtime of this automated process?
For this particular data set, it's a little over an hour, maybe about an hour and a half, because I've got about 100,000 records and I'm building about 80 different algorithms. So yeah, but if I was using a smaller data set, which I have done before, I could build this in maybe 15 or 20 minutes.
Oh, that's cool. That's rather fast. Awesome. Right, a couple of questions more, Colin. Do you see a correlation between the keywords and the date of the data sets? As in, I'm assuming the question is, are the viral keywords fixed, or do you see a shift in the sets of keywords or a change over time? I think you just showed that with the word cloud slide.
Yeah, there definitely is. So the demo I was giving you, because I was looking over a longer period, I'm trying to find recurring themes that make something viral. But there is also short-term things like that Liam Hemsworth and Miley Cyrus. I'm pretty sure if you wrote a story about that today, it wouldn't get the slightest bit viral.
Yep, makes sense.
But if you put another one about Donald Trump insulting a city, I'm fairly sure that would go viral.
Right. Right, thank you. A few Webhose questions. How much data do you collect daily? Well, that's over 10 million articles, blog posts, reviews, discussion threads, user comments per day. And this is open web, right? Darknet data we'll probably be discussing in one of our next webinars. So 10 million articles, blog posts, reviews, discussion threads, and user comments per day currently. Of course, this is growing by the day. Another question, how quickly can Webhose be about adding a site to your coverage? So yeah, very quick. We take pride in our great turnaround for new sources additions, so you can just ask us, and it would take us probably 2 or 3 minutes up to maximum of 48 hours. Let me see. Colin, couple of more for you. What is the effect of the time of the day an article has been published, and also what effect does the website that published the articles have on virality?
Sure. I'm going to jump back a few slides here. So this is the measure I used for who published it. And what we're seeing here is the biggest publishers, basically. They've been ranked by Webhose. That's one of the things I love here. I got nice generalizable measures for who published it. And it really is these big guys up here who make a big difference. Once you've ranked more than 1,500 down, you're way lower in likelihood of being viral here. Now, if I looked at the individual publishers, there's some in here that just stand out even beyond the ranking. So there's the Breitbarts of the world, there's CNN, there's Fox News. Those ones tend to stand out even beyond the patterns. The time of day I showed you before, it's the stuff published just before and just after midnight. Now, my data is in GMT, so it's UK time, even though the stories are American. So what we're really talking about is the nightly news, the stuff that comes out late afternoon and evening in the US. Okay.
Right. Yeah, interesting. You can clearly see that sources with Webhose, with higher Webhose domain ranks, this is by traffic in general, are here on the right, on the left-hand side. Sorry. So yeah, this is pretty clear. Yeah, we have a few more questions about how do we compute, how do we calculate viral score on the training data? How was the viral score computed? What exactly do you mean by viral? Is this the sum of all shares on Facebook, Twitter, LinkedIn? What is the methodology for calculating viral score and so on? Yeah, so this is kind of an interesting thing we've learned. We enriched the articles over 72 hours from the moment we crawled a post or an article, and we've learned that this is sufficient for you to be able to determine some type of social attention, right? This is per article. So from there, the road to virality is kind of paved. Exactly like with Colin's predictive model, you do need very good data with low signal-to-noise ratios for the models to work properly. But we've learned that enriching a post with 72 hours from the moment we picked it up, and if there was some amount of likes or shares or comments, this is kind of the, it means that it's on the road to virality. It doesn't mean that it would definitely go viral. This is why DataRobot are out there and models like Colin's, but it's definitely sufficient to determine some kind of virality. Let me see, what else do we have here? Yeah, we're headquarters in Tel Aviv. We're located in Tel Aviv, Israel. Company founded in 2015, and we grew from end of 2015, and we grew from 2 to 30. That's 30 enthusiastic software engineers, sales, marketing, everything here in our Israeli headquarters. Also support, customer success, DevOps, and data operations. Who are your clients? Pretty much everyone who runs a data-driven business. I mean, our data fuels enterprises, SMBs, governmental agencies, academic research, mobile apps, dashboards, you name it. Pretty much anyone who runs a data-driven business would essentially come to Webhose at one point or another. Yeah, another interesting question for Colin. To clarify, how many articles is Colin pulling down to predict?
I only predicted 6, so this was my prediction set here. I just picked 6 new articles that were outside the training period, just as an example. The data that I trained it on, I had, let me just have a look, about 65,000 stories over 4 weeks. It wasn't every story that existed. I had filtered it down to a certain geographic range. I only did in English, and that's just because I'm a bit of a Philistine and only speak English myself, and I wanted something that I understood when I read it.
Yeah, makes perfect sense. Another question about how we calculate performance score, just to make sure this is our own algorithm based on the social signals that we enrich the posts with. You can go ahead and use likes, shares, and comments, or filter by likes, share, and comments separately, and build your own recipe of what you think is a virality threshold. So we also empower you to do that without using performance score, which is kind of a harsh parameter, just to filter down or to narrow down your result sets, just to post that had a certain virality. But this is definitely not a must, and you can definitely build your own virality threshold using Webhose. Another question about tokenizing. I'm assuming that, yeah, I well, I get it. It's basically the AP with the APIs rather. Unlike the Firehose connection, which is everything that we scan with the APIs, you can pass Boolean queries and retrieve results per keyword hits. You can make it as complex as you want. Boolean logic applies, so you can use or, not, and. And also the filters that Colin showed you on the output, you can pretty much leverage everything on Webhose output as a query filter, and that way you can laser focus the results that you need. So not only a set of keywords, but domain rank and many more, the country, the language, and of course virality. We also provide some entity extraction and basic sentiment analysis over that, and so on. Okay, I think that's about it. We're trying to gather the last questions, see if there's anything new here. Yeah, for Webhose, on the open web, again, we scan news, blogs, discussions, messaging boards, Q&A pages, social networks like 8chan, Reddit, Gab, everything outside of the classic social media rooms. So Twitter and Facebook are not covered, but pretty much everything, again, outside of the, let's say, old school classic social media rooms. Also reviews for products and services. And this is only the open web. Darknet is, well, very different by nature, but just in general, Tor, I2P, ZeroNet, OpenBazaar, and messaging apps. Yeah, another one, Karen. Yeah, is DataRobot leveraging Python to train and predict on the backend?
Yes, we actually use a huge range of both packages and languages. So if I just jump back to here where I had my list of models, there's XGBoost. I've got some other libraries here. There's a Python one, some more libraries. There's some stuff written here in C++. This one is a combination of a few different languages. We've got some R models in here. There's a number of different languages sitting behind this. What we want is a huge diversity of libraries and languages so that we can find the one that works best on this data. There's a lovely theory out there called the no free lunch theorem that says that you can't know in advance which algorithm will work best on your data. And that's why I love that this is all built for me automatically. I wouldn't want to sit and manually build 80 different algorithms and train them. I'm just glad that the software does it all for me and then tells me which one's the most accurate and which one's a pretty good balance of accuracy and speed.
Oh, that's super cool. All right. Thank you for this, Colin. Yeah, one more question for you, Colin. Can your model go back and look up virality scores of past news? And if so, how far back can it go? 1 or 2 years?
That's more a question for Webhose, actually.
Yeah, I mean, assuming that's possible with Colin's models, and it does seem like that's the case. Webhose also provides archive data, so everything outside of the 30 days retention, let's say, gets archived. You can definitely access the archive through it's a different endpoint, through a different API, but you can definitely do the same with historical data. It's the same data enriched with the pretty much the same structure and the same output as you see on the live API. So the answer is definitely yes. All right, that would be all. Thank you very much. If you have more questions, please do send them over. We'll try to attend to everything. I promise to answer each and every one of you if we haven't got to your questions right now. And Colin, thank you very much for this fascinating work. Thank you for sharing that with us today.
Thank you, Webhose, for giving me the data that made this sort of analysis possible.
Brilliant. All right. Thank you, everyone, for attending, and see you on our next webinar. Colin, cheers.
Thank you.